So let us discuss this example. In this example, we have a vector field which is from R2 to R2, and we have to prove that it is continuous at 0 comma pi by 2. Okay. So you know our technique. What we do, we prove that each component function is continuous. So that's why given function is also continuous. So this is our technique. So let us write a given function first. So we have what we have. I will write here. We have what is a given function? F of xy is equal to sine x plus y comma cos x minus y. So this is a given function. So it has two component function. F1 is sine x plus y and F2 is cos x minus y. Then I can clearly mention F1 of xy is equal to sine x plus y, and what is our F2 of xy? F2 of xy is cos x minus y. So first of all, we will focus on F1. We will simply prove that F1 is continuous first, and then we'll go for F2. So we'll mention first we will prove that we will prove that F1, okay, F1 is continuous. F1 is continuous at which point? At this point, at 0 comma pi by 2. So we'll prove that function F1 is continuous at 0 comma pi by 2. Okay. So see, you know the definition of continuous function. For given epsilon, there exists delta greater than 0, like that. So at the beginning, we need to have some epsilon. So let us take one epsilon first. So let epsilon greater than 0 be given. And for this epsilon, we're supposed to find delta which will satisfy the definition. So therefore, I will clearly mention there, and simply I will mention we have to find delta greater than 0 such that, okay, which will satisfy the definition. Okay, I will write the definition here, such that norm xy minus 0 comma pi by 2, correct now, point is 0 comma pi by 2 less than delta implies mod f1 of xy minus f1 of 0 comma pi by 2 less than epsilon. Okay, so that means we have to prove that if norm of this is less than delta, mod of f1 of xy minus f1 of 0 comma pi by 2 should be less than epsilon. This thing we have to prove. So let us start to work on this mod first. Okay, we will find its value. So consider mod f1 of xy minus f1 of 0 comma pi by 2. So let us find its value. What is f1 of xy? F1 of xy is sine x plus y. Sine x plus y minus f1 of 0 comma pi by 2, same definition, x is 0, getting na, x is 0 and y is pi by 2. So that's why sine 0 plus pi by 2. So that means simply pi by 2. Okay, you know the formula, that is sine A minus sine B. You know the formula, it is 2 cos A plus B by 2 sine A minus B by 2. So this formula we have 2 cos A plus B by 2 sine A minus B by 2. So let us apply this formula here. What is our A? A is x plus y. And what is our B? B is pi by 2. So let us apply this formula. So this is equal to 2 cos, getting now cos A plus B. That means let us add them, x plus y plus pi by 2 divided by 2, correct? And sine, now we have to subtract x plus y minus pi by 2 divided by 2. Okay, so I use the formula. Now I will remove it. Okay, so this formula we use, but we should not forget there is mod. So as you know, if multiplication is there, we can take separate mod, and this 2 is constant and there is no minus sign, it's a positive number. So if you apply mod to 2, you will have same 2. So 2 mod cos x plus y plus pi by 2 divided by 2 and mod sine x plus y minus pi by 2 divided by 2. Okay, so actually we can solve it further, but before that I suggest you to take a screenshot of it, and after that we will go further. Okay, please make a screenshot of it. So let us continue. So I can write, okay, with some space we have, so let us use it. Okay, I will write directly here. So this is less than or equal to 2. So one important thing I am going to use, that is mod of cos theta is always less than or equal to 1. This important thing I am going to use. Whatever the angle inside cos, doesn't matter, its value is mod is less than or equal to 1. So this is, the angle is little bit complicated, but no need to worry, cos is there, so its mod will be less than or equal to 1. So this is less than or equal to 2 into 1. Okay, and the same, I will not touch to the last bracket, that is mod sine x plus y minus pi by 2, right now, divided by 2. Okay, so this information we use here, right? So there one more result is there, that is mod sine theta is less than or equal to mod theta for small value of theta. Okay, for small value of theta. So this thing also I am going to use. So if I use it, so I can write this is less than or equal to 2. 2 into 1, 2. And mod sine theta, this is theta, you are getting? So mod of sine theta is less than or equal to mod theta. So this is less than or equal to mod, this is theta, x plus y minus pi by 2 divided by 2. So what will happen, this 2 and 2 will get cancelled to each other. So this is equal to mod x plus y minus pi by 2. See, I am going to take a separate mod, so value will get increased. So this is less than or equal to mod x plus mod y minus pi by 2. So you remember we started with this one and finally we got this one. So therefore I can conclude here. So therefore, what can I write? Therefore, mod f1 of xy, right, minus f1 of 0 comma pi by 2 less than or equal to, what we have got, less than or equal to mod x plus mod y minus pi by 2. Okay, I will call it as star or 1, whatever you want you can call it as. Okay, so I will remove it since it, yeah, we will have a space then. Just a minute, I will remove this part. Okay, let me clear it properly. Okay, see this thing we have. So now our task is to select a delta, but we don't know really which delta we have to select, but simply I will mention, take delta is equal to, we don't know which delta we have to select. Okay, but for that delta it should satisfy the definition. Okay, so I consider, so according to definition we need to consider first, consider norm xy minus 0 comma pi by 2 less than delta. We need to consider this one, and for that definition should satisfy. Getting? So let us solve it first and let us see what we'll get. So implies, do you know how to subtract when you have a two components, how to subtract component wise? First component minus first component, second component minus second component. So x minus 0 we will have x, y minus this one we will have y minus pi by 2, correct? So this is less than delta. So yeah, norm, what is definition of norm? Square root of, so let us take square of this one, x square plus y minus pi by 2 square less than delta. To remove square root, I will take square of both sides. So it is, if you take square of both sides, x square plus y minus pi by 2 square less than delta square. See, sum of these two positive numbers is less than delta square. That means each of them is less than delta square. So that's why x square less than delta square and y minus pi by 2 square is less than delta square. Can you tell me the next step? Yes, obviously we'll take square root of both sides. So if you take square root of both sides, positive square root, obviously. So this is mod x less than delta and mod y minus pi by 2 less than delta. Okay, so let us use star now. Okay, but before that, make a screenshot of it and then we will go further. Please make a screenshot of it. Okay. Okay, then one star becomes then star becomes, okay, what can I write then? Star becomes mod f1 of xy minus f1 of 0 comma pi by 2. What we had got actually there, less than or equal to mod x plus mod y minus pi by 2, and just now we have got it is less than delta, so this is less than delta. The second mod is also less than delta, so this is also less than delta. Delta plus delta, 2 delta. Actually we want less than epsilon, so our choice of delta should be epsilon by 2. So this is equal to 2 epsilon by 2. 2 to cancel and we will have epsilon, right? So therefore I can conclude. So therefore we started with which thing? We started with this thing. So therefore norm xy minus 0 comma pi by 2 less than delta, and we got finally mod f1 of xy minus f1 of 0 comma pi by 2 less than epsilon. So definition is satisfied. That's why we can declare f1 is continuous at 0 comma pi by 2. So therefore f1 is continuous at 0 comma pi by 2. So in this way we proved f1 is continuous. Still one task is remaining. Now we have to prove f2 is also continuous at 0 comma pi by 2. But before that I suggest you to take a screenshot of it. See, now we will prove that f2 is continuous at 0 comma pi by 2. Okay, so first of all we have to take one epsilon greater than 0. So let epsilon greater than 0 be given. So for this epsilon we have to find a delta which will satisfy the definition. So we have to find, I will simply mention, we have to find delta greater than 0 such that, okay, such that it should satisfy the definition. Okay, such that norm xy minus 0 comma pi by 2 less than delta implies mod f2 of xy minus f2 of 0 comma pi by 2 less than epsilon. Okay, so you know well what will I do after this. I will start to solve the part by considering this mod. Let us find its value. Okay, so consider mod f2 of xy minus f2 of 0 comma pi by 2. Okay, so let us find its value. Mod f2 of xy, that means second component function, cos x minus y. So I will write cos x minus y minus f2 of xy, that means cos 0 comma minus pi by 2. So that means simply I can write minus pi by 2. Do you know cos absorb minus sign? If there is minus sign inside a cos, it will absorb that minus sign. So simply we will have cos pi by 2. So this is mod cos x minus y minus cos pi by 2. Okay, so actually cos pi by 2 is 0. I can put 0 here, but wait, okay, I have to use one formula here. If you know this formula, cos A minus cos B. Do you know this formula? This is minus 2 sine A plus B by 2 and sine A minus B by 2. Okay, so this formula we have to use here. Tell me, what can I write? So this is equal to, this is our A and pi by 2 is our B, correct? So let us use the formula. So this is minus 2 sine A plus B. Let us add them. That means x minus y plus pi by 2 divided by 2 and again sine, sine, okay, sine. Now we have to subtract x minus y minus pi by 2. X minus y minus pi by 2 divide by 2. See, mod is there, so we can take separate mod, and see minus sign is there, but no need to worry. Because of mod it will get cancelled. So I will remove this formula since we have already used it. It is not required now. Okay, let us continue. So this is equal to 2. I can take separate mod sine x minus y plus pi by 2 divided by 2. And here also I can take separate mod sine x minus y minus pi by 2 divided by 2. So see, one thing I am going to use, that is mod of sine theta is less than or equal to mod theta for small value of theta. Okay, for small value of theta. See, here also we have mod sine theta, there also we have mod sine theta. Okay, but I will apply this formula. Okay, just a minute, this thing also we can use, and one more formula we have, that is first of all we will use this one. Mod sine theta is less than or equal to 1. Okay, so actually we can apply for this one and that one also, both of them. That means it is applicable for both mods. But see, I will apply only for second one. I will not I will not replace it by 1. I will keep as it is. So this is less than or equal to 2 mod sine theta, that means x minus y plus pi by 2 divided by 2, and I will replace it by 1, since mod of sine theta, whatever the theta inside, it is less than or equal to 1. So yeah, now I am going to use that second formula, that is mod sine theta is less than or equal to mod theta for small value of theta. Small value of theta. So what can I write here? So this is less than or equal to 2. I can see mod sine theta. So it's mod of sine of this. This is our theta. So this is less than or equal to mod theta. That means mod x minus y plus pi by 2 divided by 2. So what will happen? 2 will get cancelled to each other, and we will have this is equal to mod x minus y plus pi by 2. Okay, actually there is no more space, so before I suggest you to make a screenshot of it, and after that we'll go for remaining part of this problem. Okay, so let us continue. So I can write this is equal to mod x plus pi by 2 minus y. So I have done I have simply interchanged them, right? See, if I take separate mod, this is less than or equal to mod x plus mod pi by 2 minus y. See, mod is there, in that you can interchange. That means mod a minus b same as mod b minus a. So this is equal to, I can write mod x plus mod y minus pi by 2. Okay, so I will write again. So therefore we started with mod f2 of xy minus f2 of 0 comma pi by 2, and what we have got, this is less than or equal to mod x plus mod y minus pi by 2. So this is equation number double star. So this is equation number double star we have got. Okay, so now our task is to select delta. Now we take delta is equal to, but we don't know which delta we have to select. So I will keep it blank and we will go further. So see, consider, okay, I'm going further. Norm xy minus 0 comma pi by 2. Okay, and this is less than delta. So definition says if it is less than delta, this one should be less than epsilon. So let us solve it now. Many problems we have solved, so you are familiar with this, what we have to do. So let us simplify. Component wise subtraction, x minus 0 we will have x, y minus pi by 2, correct? And this is less than delta. You know the definition of norm, square root of, so that's why what can I write here? So this is square root of x square plus y minus pi by 2 square less than delta. So you know that to remove square root we have to take square of both sides, correct? So this is x square plus y minus pi by 2 square less than delta square. Tell me the next step. Square of these two terms and we are adding, so this is less than delta square, so each of them should be less than delta square. So this is x square less than delta square and y minus pi by 2, so square less than delta square. So let us take square root. So if I take square root, we will have mod x positive square root, so y minus pi by 2 less than delta, then double star becomes, okay, double star becomes, see what will you get, double star, where is my double star? Here. So mod f2 of xy minus f2 of 0 comma pi by 2, I write here mod x is less than delta, so this is less than delta. I can write second bracket is also less than delta, so this is less than delta. Delta plus delta 2 delta, so my choice of delta should be less than epsilon by 2. So we can have here 2 and epsilon by 2. 2 will get cancelled and epsilon. So that's why we started here with norm is less than delta and we got mod is less than epsilon. So therefore I can declare f2 is continuous at 0 comma pi by 2. So therefore f2 is continuous at 0 comma pi by 2. So first we proved f is continuous, f1 is continuous at 0 comma pi by 2. Now we proved f2 is continuous at 0 comma pi by 2. So therefore f is also continuous at 0 comma pi by 2. So therefore I can declare therefore f is continuous at 0 comma pi by 2. So in this way we completed this example. So make a screenshot of it and after that we will stop. Thank you. Bye bye.